On this problem, we want to suppose that we have a central angle of 29 degrees, and this subtends an arc of length 35 centimeters. And our goal is to find the radius of the circle. So what we want to do is we want to use this formula where S equals R times theta. And theta represents this angle that goes in between here. This is not drawn to scale by any means. R is going to be the radius of the circle, and S is going to be this distance around the outside, like the length of this arc that goes across here, in between those two red lines. Very important thing to know on this formula is that theta, our angle, has to be in radians. In our case, theta does not start out in radians, so we're going to have to do a little bit of work to convert from degrees over to radians. So let's start with our theta, which is 29 degrees. To convert this over into radians, what we want to do is multiply by a factor that connects these two together. All right, so we have to connect degrees and radians. So in our case, we know that pi radians, halfway around the circle, connects with 180 degrees. And I'm lining up these in this direction because I'm thinking that 29 degrees is up in the numerator. And I want it to line up so that I have degrees in the numerator get to cancel out with degrees from the denominator, thus leaving us with radians for our units on this one. So to convert this over, we're going to multiply numerators together, 29 pi radians, and multiply denominators. So 1 times 180 is 180. All right, so we have 29 pi over 180 radians. All right, now we're off to plug into this formula and see what information we actually have. All right, we are given that this 29-degree angle subtends the arc of length 35 centimeters. So S is going to be 35, and that's in centimeters. So our radius is also going to be in centimeters. Things stay consistent in that fashion. All right, so let's plug in what we know. So for S, we can plug in 35 equals, well, we don't know our radius. We're going to do some work to find that. And then theta, our angle, we can represent in radians with 29 pi over 180. All right, now we have an equation with only one unknown. And again, pi is a number, so the only unknown here is r. So to solve for r, I think we're going to probably want to get rid of the fraction. So I'm going to first suggest we multiply both sides by 180. By multiplying by 180, it'll counteract this dividing by 180. And if we want to, we can go ahead and say 180 times 35 gives us 6,300. Probably go ahead and do that calculation. On the right-hand side, we still have r times 29 pi. So to get to get r all by itself, we need to get rid of that 29 and the pi. We can do this all at once if we want to, because it's all connected with multiplication. So let's just divide both sides by 29 over 29 pi. All right, what that'll do on the right-hand side is get to cancel out these 29 pi's, therefore giving us an exact answer for our radius, r. Again, this is in centimeters, so I'll go ahead and label this, that this is in centimeters, just like our S was in centimeters up here from the beginning. All right, if you needed to get an approximation for this, just get out the calculator and punch it in there. Hope this helps on setting this up and solving down, thinking about finding the radius in this situation. Good luck.